students, will look at an important technique of integration by substitution. Integration by substitution. See, first example is in such questions, if we make a careful substitution, then integral reduces to a simple integral. You can directly integrate, maybe with the help of a formula, or it becomes much easier to integrate after substitution in many questions. Let's take an example. Over here, if you put log of x equal to t and now differentiate on both sides, which gives you 1 by x dx equal to dt. Now we'll make these substitutions in the original integral. In place of log x I put t, and similarly dx by x can be replaced with dt. Now sin t can be directly integrated as minus cosine t. Now you put back the value of t from the original substitution. So this is answer to the original question. Let's take another example. This integral is square root of sin x into cosine x dx. So here, if I put sin of x equal to t and differentiate both the sides, I'll get cos x dx equal to dt. Now we will make these substitutions in the original integral, which changes to this form, which I can write like this. Now using the standard result, this is what we get. Now we'll have to put back t in terms of x from this substitution. So this would be the answer to the original integral. Let's take another example. Okay, let's take another example. This question looks very similar to the previous question. Now in this question I can write cosine cube x as cos square x into cosine x. Now using identity from trig, I can write cosine square x as 1 minus sin square x. Now you put sin of x equal to t and differentiate on both sides. Now we make the substitutions in the original integral. This can be written as, if you multiply the terms, this is what we get, and after integration this is what we obtained. Then we put back the value of t, so I'll write the answer here. This would be the final answer to the question. Okay, let's see another question. See the next question. Integral of tan theta into secant theta raised to 4. So here, if we put tan theta as t, now differentiate both sides, I'll get secant square theta d theta as dt. We can make these substitutions. If in the original integral write it like this. Now make the substitutions. In place of tan theta I can put t. Secant square theta can be written as 1 plus tan square theta, so I can write 1 plus t square here. I hope you know the identity. Secant square theta is 1 plus tan square theta. Okay, and here in place of secant square theta d theta, I'll write dt. Now we'll integrate. Okay, so we'll put back t in terms of theta. So this would be the answer to the given question. So substitution is a good technique. It can change a type of question to a simple question. See, let's take another example. See another example. This integral is secant theta to the power 4. Here I can write secant theta to the power 4 as secant square theta into secant square theta. Then using the identity, I can write secant square theta is 1 plus tan square theta. Now if you put tan theta equal to t and differentiate both the sides, we'll make these substitutions over here. Now integrate. Put back t in terms of theta. So this would be the answer to the given integral. Okay. Let's see the next question. Integral of cot x. You can write cot x as cosine x divided by sin x. Now here, if you put sin x equal to t and differentiate, now we'll make these substitutions over here. Integral dt by d from the direct result would be log t. Now I'll put back the value of t. T is equal to sin x. So log of sin x plus c would be answer to this integral. This is an important result. It's good if you can remember the result as well. Okay. Next question. Dx divided by x plus root x. In the denominator we can take root x common. We'll get this. Now if you put root x plus 1, this part, root x plus 1 equal to t, and differentiate on both the sides, this is what you get. So if I make these substitutions, these two substitutions over here, I can replace dx by root x with twice dt, and root x plus 1 is equal to t. Now this is a simple integral, answer to which would be log of t. Now you put back the value of t. T is root x plus 1. So this would be the answer to this original integral, which looks a little difficult, but careful substitution makes it much easier to integrate. Okay.